Alright, this week we're going to start graphing our linear relations. This week's goal, we're going to determine the missing values in an ordered pair, and we're also going to construct a graph from a given relation. It's going to be in a table form. We're also going to look at how to create your table of values when you're given information. Alright, so let's start by creating the table of values. So example number 1, we can take expressions and create a table of values, or a t-table, and we're going to use substitution to fill out the table. So the expression that we're given for example 1 is x minus 3. So when our input value is x is equal to 1, so when input value is 1, in our output, all we do is substitute in 1 for x. Okay, so we're just gonna zoom in here and we look and see how this is just going to be, instead of x, I'm just gonna put in 1. So 1 minus 3 gives us negative 2. Same thing here for our input of 2. I'm gonna replace the x with 2 and I have negative 1. And here 3 minus 3 gives us 0. Okay, so we used substitution to fill out the table, but after we have a few numbers like this, we can actually look at the pattern. See how this is going up by 1 every time? So I can assume that it's also going to go up by 1 every time, as long as the x values are increasing by the same amount. So for 4 and 5, it's probably going to be 1 and 2. Okay, I can confirm my answer by substituting 4 for x. So 4 minus 3 does give me 1, 5 minus 3 does give me 2, so this is correct. That's all I need to do. Okay, so to predict, you're just looking at what is happening to my output values as input value increases by 1. Right? When we have this, a related pair of x and y values, we call them ordered pairs. Okay, so for this relation, the ordered pair that we have is, for the first one, when x is 1, the output is negative 2, so that's one ordered pair. When x is 2, the output is negative 1, 3 and 0, 4 and 1. These are ordered pairs. This tells us that when x is a certain value, so 1, your output, your y is going to be negative 2. When x is 2, your output is negative 1. When your input is 3, your output is 0. When input is 4, your output is 1, and so on and so forth. Okay, so these are the ordered pairs for the relation x minus 3. Okay, so we answered this right over here. All right, let's do another example. Okay, in this case, it's the same thing. We have a t-table, or a table of values. Our input in this case, instead of calling it an n, we have, instead of calling it an x, we have an n. But that's okay, it doesn't change anything, okay? All we're doing is plugging in the value of n in our output column. So when n is equal to 1, what is our output? And our output expression is that it's 2n minus 1. 2n minus 3. So we're going to go 2 times 1 minus 3. That gives us negative 1. 2 times 2 minus 3 gives us 1. 3 times 2 minus 3 gives us 3. Okay, so all I'm doing here is I'm just plugging in 2 times 1 minus 3, 2 times 2 minus 3. So in place of n, I'm plugging in the values of x, or n, the input values. So these values are going in place of n, just like here. Okay. Once I have that, I can see, is there a pattern that I noticed? Okay, in the output column, see how everything goes up by 2 every time? So this is going up by 2. This will probably go up by 2 as long as the input increases by the same amount. So because this is a pattern on the left side, there will be a pattern on the right side as well. So on here, this will probably be 4, 5, and 5, 7. Okay. So can you predict what the next two input and output values would be? And we did that right there. What are the ordered pairs? So the ordered pairs, we just have to write them in pairs. So the first pair that we have is 1 and negative 1. And then we have 2 and 1. And then we have 3 and 3. And we have 4 and 5. And we have 5 and 7. Okay. So to predict what our next values are going to be, you're going to use the pattern on the output side, okay? And then to get the ordered pairs, you're going to put in your input and your output as a pair like this. All right, so that's how we fill out a table of values or t-tables given an equation. Okay. Now, sometimes it's going to ask us to do more than just creating a table of values. We can take our tables and then we're going to also graph them. So in order for us to graph it, we need to first complete the table of values. So let's look at our table of values in this case. So if when n is 0, we just use our output expression, which is 3n minus 5 in this case. So I'm going to substitute in 0 for n, and I have 3 times 0, which is 0, minus 5 gives me negative 5. And on here, I have 3 times 1, which is 3 minus 5 gives me negative 2. 3 times 2 is 6, minus 5 is 1. 3 times 3 is 9, minus 5 is 4. 3 times 4 is 12. Minus 5 is 7, and then the last one's going to be 10. So my ordered pair for these guys are 0 and negative 5, 1 and negative 2, 2 and 1, 3 and 4, 4 and 7, and 5 and 10. When you have an ordered pair, they are written in the order of x and then y. Remember on our graphs, our horizontal side to side is our x-axis and up and down is our y-axis. So if you look at the first values, these numbers tell us what goes in our range for our x values. So it goes from 0 to 5. So on my x-axis, I want my scale to start at 0 and end at 5. Always in a table, in a Cartesian graph, in a Cartesian plane, your middle point is going to be 0. And the x I need it to go on up to 5 or more. So I'm going to go 1, 2, 3, 4, 5. Maybe go up to 7 just in case. Okay. And then we look at our y value. Our y value is the second set in our ordered pair. So these numbers are going to be our y values. They have to start at negative 5 and all the way to 10. So we're going to label our axes. So if the middle is 0, as we go down, we're going to go into the negatives. Negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, and so on. And as we go up, we will probably go 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 10. All right, now that we have our graph set up, we have the axes, x and the y labeled. We go up by consistent increments, and we are starting at 0. Let's actually graph these guys now, okay? In order for us to graph 0 and negative 5, we go to 0 on the x and negative 5 on the y, and we draw a dot there. Okay, 0 and negative 5 goes right here. And then 1 and negative 2. So we go to 1 on x and negative 2 on y. So we draw a dot right there. And then 2 and 1, 2 on the x, 1 on the y, and the dot goes over here. See how this one ordered pair tells us where this one dot is, okay? It's telling us its location on this graph. Right, we have 3 and 4. So on x I go 3, on y I go 4, and this is my dot right there. 4 and 7, and lastly 5 and 10. Okay. And those are my ordered pairs on a graph, and that's all I do. Okay, so finding out the ordered pair was very similar to the first part of this lesson. For this part, all you're doing is now putting it onto a graph. Okay. All right, let's look at another example. Same thing here. In order for us to graph anything, we need the ordered pair, so we're going to fill out this table. Okay, I want you to pause the video right now and then fill out the table on your own, and then you can play the video again and check your answers, okay? All right, so these should be the values of the output table that you got. And your ordered pair then becomes 0 and 4, 1, 2, 2 and 0, 3 and negative 2, 4 and negative 4, and 5 and negative 6. All right, we're going to now graph these. Looking at my x values here, my x's are at 0 to 5, and my y's are going from 4 to negative 6. So keeping that in mind, I'm going to draw my axes. It starts at here. This is my x, this is my y. I start at 0 and I'm going to go all the way to, let's say, 9. And I need some negatives in my y. And I need some positives as well. 1, 2, 3, 4, 5, 6, 7. All right, now I can graph the ordered pairs. So 0 and 4, I go 0 on my x and I go 4 up on my y and then draw a dot there. I go 1 to the right and 2 up for 1 and 2, 2 to the right and nothing for y, and then 3 to the right and 2 down for -2, 4 and -4, 5 and -6 goes down right here. So that is my linear relation here graphed. Okay, if I were to draw a line connecting these dots, what kind of line do I form? I form a straight line. That is why these relationships are called linear relationships. They form a straight line. Okay, relationships that don't form a straight line are not called linear relations. All right, lastly, I want you to be able to find patterns from diagrams. So you have seen patterns like this in a diagram before. Now let's just organize this information into a table. Okay, what we know is from the first to the second diagram, it looks like we have different numbers of squares in the picture. Okay, so maybe in the top of my table I can go picture number and then number of squares. Okay, in the first one I have one square, and in the second one I have 3 squares. In the third one I have 5 squares. In the fourth one I have 7 squares. Okay, now you can tell the pattern here is that it goes up by 2, so I can probably assume how many I'm going to have in the fifth one. I'm probably going to have 9 squares. Okay. And if a question says describe the pattern in words, now I can easily describe it in words referring to my table. Okay, so as picture number increases by 1, number of squares increase by 2. That's all you do to describe the pattern in words. All right, that is all for this week. Now you can go and complete week 10, task 1.